Hello, dear students. We start our lesson. Today's discipline interchangeability, standardization, and technical measurements. And now theme 4. And name of theme, it's gauges. Gauges. Write down to your notes the name of our theme for today. And we start. Gauges are scale-less inspection tools at rigid design which are used to check the dimensions on manufactured parts. Please write down to your notes these sentences. Gauges are scale-less inspection tools at rigid design which are used to check the dimensions of manufactured parts. Measurement by gauges is easy and rapid. So they are suitable in mass production. You know that we have single production, serial production, and mass production. So the gauges we can use in mass production. So they are suitable in mass production. Instead of measuring actual dimension of each part, with is time consuming and costly, the conformance of part with tolerance specification can be checked by gauges. And now we see the table with characteristics of measuring instrument and gauges, different between gauges and other measuring instruments. So first row. Measuring instruments, they carry calibrated scales, and gauges without scales. Gauges without scales. Measuring instrument, they are general purpose instrument. They are general purpose instrument. It's measuring instrument. And gauges, they are made for a particular component. Measuring instrument measures actual dimension of part. And gauges checks whether the dimensions of parts are within specific tolerance limit or not. Check whether the dimensions of parts are within the specific tolerance limit or not. And measuring instrument, time consuming and not suitable for mass production. So it's not suitable for mass production. And gauges, easy and rapid, suitable for mass production. Easy and rapid, suitable for mass production. It's gauges. Easy and rapid, suitable for mass production. Measuring instrument, skilled labor to handle. And gauges, no need skilled labor. Increased cost, it's measuring instrument, and gauges, reduced cost. Reduced cost. Increased cost, it's measuring instrument, and gauges reduced cost. It's very important. And the last one, measuring instrument, adjustment in required. And gauges, no adjustment. So we can see the many options, good options for gauges. And now I want to show you some video about gauges. What is the gauges? Gauges. Wait a minute, please. Pause. So, video about gauges. What is the gauges?
Double-ended
Plug gauges.
double-ended plug gauge. In this video, we are going to see about double-ended plug gauge. In this type,
You can see a gauge, plug gauge with double-ended first end and second end. First end go side and no go side.
go end and no go end.
Go
are
end
arranged
and
on
no
both
go
sides
end.
of the plug workpiece. No go. The no go end must not go into the component feature.
The no-go end must not go into the component future. From the other side, we can see go end.
Go. Go end of the gauge must go into the feature of the component being checked.
Go end of the gauge must go into the future of the component being checked. And you can see that it's true. So this part is valid.
The double-ended limit plug gauge is used to test the limits of size.
The double-ended limit plug gauge is used to test the limits of size, not the value of the dimension, only to test the limits of size.
Test the limits of size. This type has the advantage of easy handling. Single-ended plug gauge. In this video, we are going to see about single-ended plug gauge.
It's a plug gauge again, but
Component
only single-ended.
no go.
Go and no go plug gauges. The same procedure.
It is used to test the nominal size of a cylindrical hole.
Go plug
This
gauge.
is generally used for sizes over 63 millimeter and up to 100 millimeter. Progressive plug gauge. Let us see a 3D model of a progressive gauge. These plug gauges are used for checking the diameter of a straight hole. Checking the diameter. Okay. Let us see a 3D model of a progressive gauge. These plug gauges.
You can see two surfaces. First surface, it's go surface of plug gauge, and second no-go surface of plug gauge.
Are used for checking the diameter of a straight hole. The go gauge checks the lower limit of the hole and the no gauge checks the upper limit.
Remember this and write down to your notes that the go gauge checks the lower limit of the hole, and the no-go gauge checks the upper limit. Go gauge checks the lower limit of the hole, and the no-go gauge checks the upper limit.
Thread gauge. Let us see a 3D model of a thread gauge.
Thread gauge.
Internal threads are checked with thread plug gauges of go and no-go variety, which employ the same principle as the cylindrical plug gauges. Ring gauge. Let us see a 3D
Next
model
type of
ring
gauges, it's ring gauge.
Ring gauge.
You can see go ring gauge and no go ring gauge. And workpiece is a cylinder. It's a shaft. They are used to check
Separate gauges are used for checking go and no-go sizes.
for checking go and not go sizes. The no-go end must not go into the future because it's no-go end. Go end.
Go end of the gauge must be go into the feature of the components being checked. Snap gauge.
Next type of gauges, snap gauge.
Model of a snap gauge. Workpiece. Snap gauge.
Go and no-go sizes of snap gauge.
Snap gauges are used as quick means for checking sizes within certain limits by comparing the size of the part with the opening of the gauge. The no-go end must not go into the feature. Go end of the gauge must be go into the feature of the components being checked. Adjustable caliper gauge. In this video, we are going to see about
Adjustable caliper gauge. Next type of gauge, adjustable caliper gauge.
It consists of adjustable anvil, fixed anvil. Go, it is marked in green color. Place the slip gauge on the anvil. See the go and no-go standard with help of slip gauges for specified limits of size. The adjustable caliper gauge can be used for checking external sizes in any place along the length of a work.
And we are continue our lecture. And the next slide starts. The next slide, types of gauges. Types of gauges. Plane gauges are used to check plane, other head holes and shafts. And we start classification. According to type. Standard gauge. If a gauge is made as an exact copy of the matching part of component to be checked, it is called standard gauge. A standard gauge can't be used to check interference fit. It has limited application. Next type of gauges, limit gauges. Limit gauge. Two gauges are used to check each dimensions of the part, upper and lower limit. We check each dimensions of the part, its upper limit, upper dimension of the part, and lower limit dimension of the part. These are go and no-go gauges. These are go and no-go gauges, as you can see on the previous video. Go gauges check maximum metal limit, and no-go gauges check least metal limit. Maximum metal limit is mml, least metal limit LML. One more time, please write down to the your notes. It's very important. These are go and no-go gauges. Go gauges check maximum metal limit, and no-go gauges checks least metal limit. These are widely used in industries. A part is considered to be good if the go gauge passes through the work and the no gauge fails to pass under the action of its own weight. This confirms the actual dimension of part within the specific tolerances. If both the gauges fail, it indicates that hole is undersized and shaft is oversized. If both the gauges fail in indicators that hole is undersized and shaft is oversized. Following gauges are the most commonly used in production work. The classification is principally according to the shape of purpose for which each is used. First, snap gauges. Write down to your notes all these types of gauges. Snap gauges. Plug gauges. Ring gauges. Next type, lens gauge. Form comparison gauge. Thickness gauges. Thickness gauges. Indicating gauges. Pneumatic gauges. Next time, electric gauges. electronic gauges, number 11, it's projecting gauges, and 12, multiply dimension gauges. Multiply dimension gauges. Multiple dimension gauges. Write down to your notes these types of gauges. According to the purpose, classification of gauges. According to the purpose, workshop gauges, A. B. Inspection gauges. C. Reference of master gauge. And D. Purchase inspection gauge. Classification according to purpose. Classification according to the form of the tested surface. A. Plug gauges for checking holes. And B. Snap or ring or gap gauges for checking the shaft. Snap gauges for checking the shaft. And 3, according to the design. Single limit or double limit gauges. It's A. B. Single-ended or double-ended gauges. And C. Fixed and adjustable gauges. Fixed and adjustable gauges. And now you can see the different types of gauges on this figure. And you can see snap gauges and plug gauges. 2 types of gauges, snap gauges and you can see the plug gauges. Plug gauges. If we look to the plug gauge, we can see 2 sides, go side and no go side. Size of diameter, it's 10 nominal diameter 10 millimeters, and H7, it's fundamental deviation, and IT grade 7. It's grade, tolerance size. Lower limit deviation of the size and upper limit deviation of the size. So it's diameter of the hole 10 millimeters. Upper limit deviation plus 0.015, 0.015. Lower limit deviation is 0. It's diameter of the hole that we can control by these plug edges with this size of the diameter and grade, with go side and no go side. Next example, diameter, nominal diameter of the hole, diameter 20. Upper limit deviation of the hole plus 0.021. Lower limit deviation of the hole 0. Or H7. Fundamental deviation H7 IT grade. Its grade or tolerance size of the hole with nominal diameter 20 millimeters. And its go side and no go side of the plug gauge. The snap gauges on this picture, you can see the snap gauge with go and no go sides. Diameter of the shaft that we can control by this snap gauge. Its diameter of the shaft, diameter 25, its nominal diameter. J6, J, its fundamental deviation, and 6, its IT grade or tolerance size. Upper limit deviation plus 9 micrometers. Zero point zero zero 9. Lower limit minus 0.004 millimeters. On the snap gauges, you can see its deviations in micrometers, in microns. And you can see the different type of snap gauges with go side. It's first go side and no go side. It's no go, it's go. And we are continue. On this slide, you can see ring gauges. Go ring gauge and no go ring gauge. It's a ring gauge for the thread. And lens gauge. Lens gauge. On this slide, you can see form comparison gauge, indicating gauges, thickness gauges, and pneumatic gauges. Thickness gauges and pneumatic gauges. Electric gauges, projecting gauges, electronic gauges, and multiply dimension gauges. Electric gauges, electronic gauges, multiply dimension gauges, and projecting gauges. Limit plug gauge. Limit plug gauge. Write down to your notes this figure with no-go and go sides of the plug gauge. The go plug gauge is the size of the lower limit of the hole, while the no-go plug gauge corresponds to the upper limit of the hole. In use, the go end should fully enter the part. The no-go end should not. In use, the go end should fully enter the part, like in this figure. And the no-go end should not, like in this figure. Go side of the plug gauge, no-go side of the plug gauge. Snap gauge. You can see again go side and no go side. Go side of snap gauge. Go side of snap gauge and no go side of snap gauge. The go snap gauge is of a size corresponding to the upper limit of the shaft. You can see the shaft. Go snap gauge is of a size corresponding of the upper limit of the shaft. While the no-go snap gauge corresponds to the lower limit of the shaft. No-go snap gauge corresponds to the lower limit of the shaft. In use, the go end should fully enter the part. The go end should fully enter the part. The no-go end should not. Like on the figure that you can see on our screen. Write down to your note this figure and write down to your note these sentences about go side and no-go side of the snap gauge. And now I want to show you next video about gauges, different types of gauges in metrology.
Metrology is a significant department of mechanical engineering that deals with the measurement of a workpiece. Metrology is oftentimes called the science of measurement that depends upon two significant factors. The factors are time and quantity, which has to be measured by an engineer in order to ensure the precision of the workpiece. Every material has some degree of error in it that can impact negatively on the mechanical efficiency of a machine component. Therefore, for removing those errors from a workpiece, some measurement tools are devised by engineers such as surface texture measurement device, tolerance measurement device, screws threads measurement device, and so on. Gauge is the tool used by engineers to rectify errors in terms of linear measurement. Linear measurement deals with measuring lengths, heights, diameters, etc. It is also used by engineers to secure variance in a workpiece. In this assessment, gauge and its types are critically analyzed briefly in all the possible ways. Everyone is seeking for an appropriate knowledge about gauges due to the conciseness of the description. If we look into the definition of gauge, a gauge is an inspection tool that is used by engineers to measure the tolerance limit of a component. Gauges are mainly utilized by engineers in order to segregate the appropriate dimension of a workpiece. Some fundamental limitations are present within which a gauge should be made by manufacturers. Therefore, if the gauge seemed accurate in relation to ideal gauge, then the workpiece should be measured with that gauge. The operator can use gauge without having vast knowledge in operating those mechanical components. Also, gauges consume less time as compared to other measuring devices. Now let's discuss about the types of gauges in metrology. Plain gauge is defined as the dimension measuring or inspective tools, without a scale to measure any manufacturing part of tools. In order to check shafts and the holes, plain gauge is used. Plain gauge is classified into 4 different types. Those types are as follows. Depending on the manufacturing principle and type, the plain gauges can be classified as standard gauge, limit gauge, indicating gauge, and combination gauge. Depending on the purpose of use, the plain gauges can be classified as workshop gauge, inspection gauge, and master gauge or reference gauge. Depending on the function, there are some dimension measuring plain gauges, which include the inside dimension measuring gauge, including plug gauge, and pin gauge, the outside dimension measuring gauge, including snap gauge and ring gauge, and both sides dimension measuring gauge, including caliper gauge, geometric measuring gauge, gauges for concentricity, gauge of taper, and gauge of profile. Depending on the design, the plain gauges can be classified as single limit and double limit, single-ended and double-ended, fixed and fastened, and geometry measuring gauge. Now, let's discuss about each of them in brief. Number 1, depending on the manufacturing principle and type. Standard gauge. A standard gauge can be defined as the measuring tool that checks the copy of the mating part of the material. This gauge cannot be used by an engineer due to the existence of tolerance in a workpiece. Limit gauge. A limit gauge is defined as the gauge that is used to measure a component by 2 limits. One is high and another is low. So, there are 2 gauges to measure the dimension of the material. 2 gauges are the go gauge and the not go gauge. The part of the component has to pass through the go gauge, and for the not go gauge, it has not to pass. This gauge is widely used in industries. Indicating gauge. An indicating gauge is defined as the gauge which is used to measure a part of a material and shows the measurement on a display. This gauge displays the measurement on the indicator or display, so it is termed as the indicating gauge. This gauge is complex than other gauges. The best example of the indicating gauge is dial gauge. Nowadays, such indicating gauge has a system of the visual display. And combination gauge. A combination gauge is defined as the gauge which can take more than one dimension of the parts of the material consecutively. It is very useful as at a time more than one measurement of the parts can be taken. It consumes less time and produces more efficient results. Number 2, depending on the purpose of use. Workshop gauge. A workshop gauge is defined as the gauge which is used to measure the parts of the material at the time of production. This gauge is used in the production time at the workshop, so that this gauge is named as the workshop gauge. The workshop gauge is designed like that, where the tolerance is in the center line, so that workshop gauge is very useful in the plants or workshops rather than the others. Inspection gauge. An inspection gauge is defined as the gauge which is used by the inspectors in the plants after finishing the manufacturing of the products to accept it, as the acceptance or the rejection is depending on the gauge measurement, so that tolerance of this inspection gauge is slightly more than the workshop gauge. If the tolerance of the material part is high, then it is accepted, otherwise the material should be rejected. And master gauge or reference gauge. A master gauge is defined as the gauge to check the other gauges as the expenditure is involved. The measuring instruments, optimizers, comparators, slip gauges, etc. are checked by the master gauge or reference gauge. All the other gauges are checked by this gauge, so that this gauge is called the master gauge. It is very useful because the efficiency of the other gauges depends on the master gauge. If the master gauge cannot check the other gauges or instruments properly, then those gauges and instruments cannot give accurate results. Number 3, depending on the function. Dimension measuring gauge. A dimension measuring gauge is defined as the gauge which measures very small parameters of the parts of the material with very high accuracy. These dimensions are depth, height, diameter, etc., and are measured by the dimension measuring gauge. This gauge is used to get very specific and accurate dimensions. This dimension measuring gauge is classified in the other 3 types, which include inside dimension measuring gauge. Inside dimension measuring gauge is used to measure the inner or inside diameter, width, height, etc. In an example, the inner diameter of a bolt can be measured by plug gauge. Inside dimension measuring gauge is classified in different types, such as plug gauge and pin gauge. A plug gauge is a cylindrical shaped go and not go type gauge. It is used to measure the diameter of a hole like things with accuracy. In order to measure the parts, it has to pass a measurement and another one has not to pass the measurement. That is called go and not go measurement. Whereas, a pin gauge generally works on the same working principle as the plug gauge, which is used to measure the diameter which is more than 75 millimeters. Measurement of the width of the slots or grooves is done by pin gauge. It is measured across cylinder bore on the gauge placed as lengthwise. Outside dimension measuring gauge. The outside dimension measuring gauge is used to measure the outer or outside diameter, width, height, etc. As an example, the outer diameter of a bolt can be measured by snap gauge. Dimension measuring gauge is classified in different types, such as snap gauge and ring gauge. The snap gauge is the gauge that is U-shaped go and not go type gauge. It has jaws by which it checks the accuracy and tolerance. In order to measure the parts, it has to pass a measurement and another one has not to pass the measurement. That is called go and not go measurement. Here go is a high or maximum limit and the not go is the low or minimum limit. Whereas the ring gauge is the same as the snap gauge, but it is separated the go and not go pass or in a single ring. Both sides dimension measuring gauge. A both sides dimension measuring gauge is used to measure the outer or outside and inner or the inside, both diameters, width, height, etc. In an example, the outer and inner both the diameters of a bolt can be measured by calipers. Outside dimension measuring gauge is classified in different types, and those are caliper gauge, geometric measuring gauge, gauges for concentricity, gauge of taper, and gauge of profile. The caliper gauge is the gauge that is used to measure the distance of an object between the 2 different sides. It is very useful as it can give more accurate results and very easy to use. Such examples are vernier caliper, dial caliper, digital caliper, micrometer caliper, etc. The geometric measuring gauges are defined as a measuring device that can measure its concentricity, taper, and profile. Mainly the geometric measuring gauge is used to measure the roughness or unevenness of the surface. There are several types of measuring and calculating procedures for roughness characterization through its concentricity, profile, and so on. The concentricity gauge is used to measure run-out by revolving the cylinder or the loaded round on two pairs of bearings that are captured in anodized aluminum blocks. This gauge mainly measures the circle of the plane. The taper gauge is basically used to measure the internal tapers. This gauge looks like an internal gauge in the shape of a frustum of a cone. And the profile gauge or contour gauge is a tool that is used to draw the profile or copy it onto another surface. Number 4, depending on the design. Single limit and double limit. The single limit gauge has a jaw that is fixed that makes the gauge limited, but in the case of the double limit gauge, it has a movable jaw that can be doubled with the help of the adjustable jaws. Single-ended and double-ended. The single end gauge has a single end that could be either go end on or go end button. Double end gauge has both ends. Its one end is go end, another one is an go end. Fixed and fastened gauges. In fixed end gauge, both jaws are fixed at the same time, but in fastened end gauge, only one jaw can move or adjustable. These types are mainly a type of snap gauges. Concerning the discussion on gauges and its types, it can be asserted that the field of metrology is incomplete without the gauges. The precision of a machine component is one of the most important factors that decide the mechanical advantage and well as the efficiency of the machine component. Due to this reason, proper knowledge about gauges should be gathered by engineers before making a machine component. Working of a lathe, milling, grinding or other metal forming process cannot be made within the tolerance limit and without measuring their error. In regards to this, gauges plays a vital role. The discussion in this video lecture is very brief, that just occupies the types and its descriptions. Hence, some gaps exist in this assessment, although, if an engineer wants to seek knowledge on gauges, this assessment can be a fruitful one. Thank you.
And we start the next slide, Taylor's principle of gauge design. Taylor's principle of gauge design. Taylor's principle is the foundation of the limit gauge design. According to Taylor's principle, the GO gauges should check all the possible elements of dimensions at a time, roundness, size, location, etc. And the no-go gauges should check only one. It states that 1. Go gauges should be designed to check the maximum metal limit, while the no-go gauges should be designed to check the least metal limit, LML. Go plug gauge should correspond to LL of hole. No-go plug gauge should correspond to UL of hole. Go snap gauge should correspond to UL of shaft. No-go snap gauge should correspond to LL of shaft. Least limit of shaft. Lower limit of shaft. So, one more time. Go plug gauge should correspond to lower limit of hole. No go plug gauge should correspond to upper limit of hole. Go snap gauge should correspond to upper limit of shaft. And no go snap gauge should correspond to lower limit of shaft. The difference between the go and no go plug gauge, as well as the difference in size between go and no go snap gauge, is approximately equal to the work tolerance. Please write down to your notes Taylor's principle. Go gauges should be designed to check the maximum metal limit, And no-go gauge should be designed to check the least metal limit. To plug gauge, go gauge must be of corresponding section and preferably full length of hole so that straightness of hole can also be checked. The no-go gauge is relatively short and its function is dependent not only the diameter but also on the circularity of the hole. To snap gauge, go gauge must be corresponding section and preferably full length of shaft so that straightness of shaft can also be checked. The no-go gauge is relatively short and its function is dependent not only on the diameter but also on the circularity of the shaft. And now you can see the dimensions of the whole shaft and of the feet. 50, its basic size or its nominal diameter of the hole. Why hole? Because you can see big H. Big letter, it's always for hole. Small letters, it's always for shaft, like in the B, figure B. You can see F, small f, and so it's always for shaft. H is fundamental deviation. And 8, it's IT grade. So nominal diameter 15, H8. It's tolerance grade H8. For the shaft, diameter 50, it's nominal diameter or basic size. Small f, it's fundamental deviation of the shaft. And 7, it's IT grade. IT grade 7. And F7, it's tolerance grade. Together, it's tolerance grade. And we can see F, it's small, so it's parameters of the shaft. And the feet shaft with the hole. Basic size or nominal diameter of the shaft and of the hole, it's 50 millimeters. Above the line, H8, big H, it's for holes, and its fundamental deviation of the hole, 8 IT grade. And under the line, small f, 7, it's fundamental deviation and IT grade of the shaft. And together it's a fit with hole tolerance and shaft tolerance. Schemes of placement of fields, of tolerances, of workshop and inspection gauges. You can see tolerance field of the hole, tolerance field of the hole. No-go side. It's tolerance field of workshop, no-go workshop, no-go side of workshop gauge for the hole. And it's go side, tolerance field of the go side of workshop gauge for the hole. For the shaft, tolerance field of the shaft. Upper limit deviation of the shaft, lower limit deviation. It's upper limit deviation, it's lower limit deviation of the shaft. And you can see first, it's no-go side. No-go side. It's tolerance field of workshop gauge and tolerance field of inspection gauge. Tolerance field of workshop gauge of its no-go side and tolerance field of inspection gauge of its no-go side. That can be used to control the lower limit deviation of the shaft. Go side. Tolerance field, its tolerance field of the go side of workshop gauge to control the shaft, and tolerance field of inspection gauge of its go side. And you can see wear limit and inspection and tolerance field of inspection gauge that we can use to control wear limit. Please write down to your notes this scheme on the figure that you can see on this slide. Do it now. Write down to your notes. And now write down to your notes these two tables, formulas for determining the executive size of gauges. Formulas for determining the executive size for gauges. Write down to your notes this table with formulas. For the nominal part size up to 180 millimeters, and for the nominal part size from 180 to 500 millimeters. The difference between this table and this table, it's that we use alpha for the nominal part size from 180 to 500 millimeters. You can see plus alpha, minus alpha, and alpha suffix 1. It's a difference between first tables and second table. When you finished this table, our lesson will be finished, and I see you later on the next week. Goodbye and have a nice day.